Hi, can you see my PowerPoint?
Yes.
Okay. Hi, I'm Ziyu Xia. My project is talking about cluster analysis of COVID-19 database in USA with data visualization. In this project, I use the dataset All State History, which contains statistics of COVID-19 virus in each US state as of October 31st, 2020, to analyze the transmission trends of the COVID-19 virus and how severe the situation is in different states and whole USA. The all-state history dataset has 13,607 cases and 17 variables in total. Each case represents a set of observation data about COVID-19 virus epidemic in a US state in one certain day. At the time of writing this report, the date have been updated to October 31st, 2020. The variables that will be utilized in this report and their meanings are shown here. Next, analysis the transmission trends of COVID-19 virus in the whole USA. Compare how the total number with positive results, the total number of deaths, and the total number of recovered change over time in left figure. The right one shows that it can be observed that there is a curvilinear relationship between variables positive and variable deaths. The method utilized is hierarchical agglomerative clustering. The algorithm is as follows. Define each observation as a cluster, calculates the distance between every cluster and every other cluster. Combine the two clusters that have the smallest distance. This reduces the number of clusters by 1. Repeat step 2 and 3 until all clusters have been merged into single cluster, contains all observations. Here is the cluster diagram. The most number of cluster is 4 here. Texas, California, and Florida are type 2. Missouri, Illinois, and Wisconsin are type 3. The states in orange here are type 4. The others, blue, are type 1. In this section, data was updated to February 2021. Since the curvilinear relationship between variable positive and deaths, the weekly increase date is used for data visualization, showing on map and line chart. Due to some states did not update date every day, so that it would cause missing data problem. Daily increase date is not used in this section. The map is showing each state with different color according to its risk level. Consider the color blindness. Blue color is used for legend of map. The legend used here is includes 6 risk level according to CDC website. The darker color means the higher risk level. In figure, it shows weekly increase case in each state at week 8, 2021. Uh, when using mouse, click on the state uh, like this. It will show the weekly increase case of its state shows in the line chart with black lines and blue dots. The red dots means date point of choosing week. The orange vertical line is helped for locate the week on x-axis. For example, we could see the trends of COVID-19 spread in here in Massachusetts. From the beginning of testing COVID-19 cases, the weekly increase case rise a lot here. It went to first peak at the last week of April. After MA ordered the residents to wear masks on May 6th, the weekly increase case decreased and kept steady until the beginning of October here. The weekly increase case grew a lot due to the cold weather. However, the second peak came after Thanksgiving holiday here. And then the third peak showed after Christmas holiday. From the beginning of 2021 to March, the weekly increase case dropped fast. So the government policy with mask requirement is one of factor of controlling COVID-19 spread, and the holidays of gathering and parties is another vector of COVID-19 spread. A weekly calendar is below the map here. It can let the audience to choose the weeks they pick. Each state on the map change color with the weekly calendar according to the weekly increase date of this state. For example, here, like here, Illinois, it's 2020, a week 10, which is the beginning of recording COVID-19 database in USA. The map visualization shows a lot of states were below low risk level. However, like it's here week 49 in Wyoming at 2020, which is the next week of Thanksgiving holiday. The map visualization shows most of states were at severely high risk level. With the show cluster button, the outline of states in different four clusters are presented as different colors: purple, yellow, red, and aquamarine. Also, the outline could be hidden with hide cluster button. Another interactive slider is population slider here.
Please keep in mind that you have about 1.5 minutes remaining of the 12 minutes. If you could maybe wrap up.
With still cluster button, audience could find the states in the same cluster and almost same range of population. The population of states in type 1 clusters are almost below 7 million. The population in type 2 cluster range more than 20 million. The range of population in type 3 cluster are around 6 million. And in type 4 is between 5 million to 20 million. So population is one of the vector of COVID-19 virus spread. Conclusion, I used hierarchical clustering method to analyze the dataset of COVID-19 in USA, and all states are divided into 4 clusters. We have a detailed understanding of how the COVID-19 virus is spreading in the United States and the different transmission situation of COVID-19 virus in different states by using data visualization. The vivid data visualization with map and the line chart shows some important vector of COVID-19 spread in USA. Government policy with face mask requirement, holiday of gathering and parties and populations. The most trouble situation is in type 4 cluster, Texas, Florida, and California. Should be paid attention. These 3 states have largest population. Florida and California are 2 most popular states which people would like to go during holiday for gathering and parties. The number of positive and deaths are much higher in these 3 states than the others. Through these 3 states should take more effective measure to prevent future spread of COVID-19 virus, such as government policy. My future work, I may add K-mean cluster with data visualization into the project later. I want to change the date to weekly increase case per population density. It will make it more logical. If I have more time, I will add predict modeling also. Okay, thank you.
Thank you. So could you elaborate on what kind of hierarchical clustering did you use? For example, what kind of similarity measure, as well as was it single linkage, words linkage, or any other particular method?
What?
Did you code this in Python? How did you do the coding? Which language?
I do that in Python, yeah.
Okay, so
no, the date part I use Python to analyze the date, and the website part I use D3.js.
Okay, so what kind of similarity measure did you use for the clustering?
hierarchical or agglomerative clustering.
Okay. Do you think that k-means clustering could be more beneficial than hierarchical?
Yes.
Okay, thank you. Any other questions, please? You have two questions in the chat. Do you want me to read them for you, or would you rather access the chat yourself?
Okay, or the chat. It's here. Okay, no, it's only D3 for this page. Yeah, it was 20 years to make interactive item to the class. What tools? I use Python to analyze the data and just D3 to make the website. No other things I use. Yeah, thank you. Any questions?
Nathan, are you okay with the answer? Do you wish to pursue further line of questions?
Yeah, you just said that the clusters were kind of correlating with the population size. But did you see any relation to what like the governor of the state sets for like mask wearing or public gatherings or things like that? Like, did you look into the?
Not yet. I just look about the government order to wear the mask. The government policy is only about this.
Okay.
Any further questions, please?
I had a quick question. Is this, since it's a website, is this available for people to try out and use?
Not yet, and not posted yet.
Okay. Will it be in the future, do you think? The plan?
There might be some little thing to fix. If I fix all of those things, I may, try to post it. Like here, you see this job here. Maybe my code skill is not very good, because here is the last week of 2020, and in 2021, the first, second, and third day, they use this point to show it. So yes,
great, thank you.
some little things to fix.
Thank you. Any further questions for this presenter? We're already well behind. All right, let's thank our presenter and move on to the next data science senior, Brian Cornett.
Hello.
Whenever you're ready.
Yes. Can everyone see this?
Yes.
Can you hear me?